Hello and welcome to this lesson on box plots. Hopefully you have completed the work on cumulative frequency from last time, had a go at some of the questions from the exercise and also the Heggerty Maths linked to it. Once you've done that, you are now ready to do this lesson on box plots. So if you want to pop today's date and the title in your exercise book and then get ready to have a go at this do now question. So the do now question, Zara recorded the duration in minutes of 60 helpline telephone calls. She produced this cumulative frequency curve for the data. The question wants us to calculate an estimate for the median length of a telephone call and also an estimate for the interquartile range. If you just pause the video, have a go at this question, and then when you want to go through, get ready to resume. So for the median then, as there are 60 helpline telephone calls, we draw a line across halfway up the cumulative frequency curve, so 30 across to the curve, and then we read down the axis, so the median time is 10 minutes. Then for the interquartile range, this is the upper quartile, subtract the lower quartile. So for the upper quartile, this is 3/4 of the way, so 3/4 of 60 is 45, so reading across to the graph and down. So this is your upper quartile, and the upper quartile is approximately 11.5 minutes. The lower quartile, remember, is 1/4 of the way up the cumulative frequency axis, so to 15. So reading off a value for the lower quartile would be approximately 7.8 minutes. An estimate then for the interquartile range, remember the interquartile range is the upper quartile, subtract the lower quartile. So 11.5 subtract 7.8. So an estimate for the interquartile range, remember this is how spread out the middle 50% of the data is 3.7 minutes. Don't worry if you were 0.1 out, they normally give you leeway in an exam question. So the success criteria for today, the bronze objective is to find the median and quartiles of data. This we looked at when we did the cumulative frequency lesson. So moving on to a silver objective, today we are going to be looking at drawing a box and whisker plot. Sometimes it's just called a box plot. And we're also going to be looking at interpreting them as well and comparing. So when you look at this PowerPoint without the video recording, if you click on this video link here, this will take you to a video on the Corbett Maths website if you would like to see a different video on the same topic. So thank you to Corbett Maths and also again to Dr. Frost, as I have used some of his PowerPoint slides throughout this. So box plots then. A box plot allows us to visually represent the distribution of data. So we have some data below. Let's think that these are the marks that some students have got in a test. So the minimum score a student got was 3 and the maximum was 27. Maybe the test was out of 30. The median score of a child was 17 and they've worked out the lower and upper quartile values for us already. So to sketch this onto a graph, notice here they've drawn a scale. This you can do in your exercise book or on graph paper, and it needs to accommodate all of the values from the minimum to the maximum. So I need to be able to put 3 on here, hence why we've started at 0. We need to go up to 27, so it makes sense to take the scale up to 30. So the median then, the median is 17 and we draw a line here. There's no hard and fast rule about how long this line needs to be. Maybe if you're in your exercise book you could do it 2 or 3 squares in width. So the lower quartile, we draw a line at 15. Ignore this at the moment. So this is the 15 line, it's the same length as the median line. And the upper quartile of 22 we draw here. And then we join this all together and this is what is known as the box plot. So here the first line represents our lower quartile, the middle line, so the second line along, because it's not exactly in the middle, is our median line, and the line at the end of the box plot is the upper quartile. Then what we do is we plot the minimum and the maximum. So the minimum was 3. The maximum is 27. Notice these lines are not as long as the lines for the lower quartile, median and upper quartile. They're about half the length, and we generally draw it within the middle of the box. But again, no hard and fast rule, you just want it to look like the diagram we've got here. And then we join these up to the box, which is why sometimes you'll see that it's called a box and whisker plot. So how does this help us represent data? So the range then is represented by this width here, because we know it's the maximum value, take away the minimum value. And also on here we have the interquartile range, because we know the interquartile range is the upper quartile, subtract the lower quartile. So we are able to see this visually as well, and it helps when later on when we start comparing box plots. So being able to interpret a box plot then, here we've got a box plot drawn for us, and it's showing some ages in years. So you could pause the video and have a go at these true or false questions. So true or false, the right box, so this box here, represents more than the left box. Well, actually this is false, because each of these boxes represent 25% of the data. Remember, from the lower quartile to the median, that's 25%, and also from the median to the upper quartile, that's 25%. So the ages are more spread out above the median. Well, here's the median. So this is true, because the wider the box, or the wider the whisker, the more spread out the values are within that 25% of the data. So from the median line to the upper quartile represents 25% of the data, and so does from the upper quartile to the maximum value, that is 25%. And from the lower quartile up to the median, that's also 25% of the data, and from the minimum up to the lower quartile. Now, as the data is more spread out in the positive direction, we say that the data is said to have positive skew, but you're not expected to know about this term for GCSE. So let's test your understanding then. You may also be given a list of values and be asked to draw a box plot. So we have to note down the minimum and maximum values. Well, we can see those quite easily are 5 and 20. We need to work out the median and the lower quartile and upper quartile in the same way that we did in the previous lesson. So the median then is the middle value. So this will be the 8 here. And the lower quartile, now remember, because we have got an odd set of data, so here we have 9 pieces of data. So the 8 is the median, so we ignore this, and then we find the median of these values for the lower quartile, which will be halfway between here. So the lower quartile will be 6.75, and the same for the upper quartile, so we will ignore the median, and then we will work out the median between the upper values, so the 9 to the 20, so the upper quartile will be 13. Now let's sketch the graph, the box plot. So you could pause the video and have a go at it. Here's what it should look like. So again, the median line at 8, the lower quartile at 6.75. It will be easier in your book with the squares to be able to draw this. The upper quartile at 13. Your minimum value at 5, maximum at 20, and then you draw in the whiskers. So have a look to further test our understanding. This is a past Edexcel GCSE question. Colin took a sample of 80 football players. He recorded the total distance in kilometres each player ran in the first half of their matches on Saturday. Colin drew this box plot for his results. There were 80 players in Colin's sample. Work out the number of players who ran a distance of more than 5.6 kilometres. You could pause the video and have a go. Now 5.6 kilometres, now if we look at the scale here, from 5.5 up to 6 there are 10 small squares. So for 0.5, if we share that by 10, each little square will represent 0.05 kilometres. So this line here, the line for the upper quartile, is actually the 5.6. And we know from the upper quartile to the end of the data, this represents 25% of the data. So each player ran, so the whole box plot shows us the total distance in kilometres that each player ran, and as we want to know the number of players who ran a distance of more than 5.6 kilometres, we want to work out 25% of that 80, because this is what is represented here. So this would be 20 of the players. Comparing box plots then, this is very common in GCSE, and the best way is to compare a box plot to be able to get maximum marks is you must be comparing the median, and you must be comparing one of either the range or the interquartile range. So here we have box plots comparing house prices of Croydon and Kingston upon Thames. Compare the prices of the houses in Croydon with those in Kingston. So if I reveal this one first, this one is the comparison of the median. So the median house price in Kingston was greater than that in Croydon. And generally in an exam, when it's easier to read from the scale, you can actually quote by how much it was greater as well. Then you need to compare either the interquartile range or the range. Remember, the interquartile range is the distance between the lower quartile and the upper quartile. So is this width here. So you can see here then the interquartile range in Kingston. So this width is much greater than the interquartile range of Croydon. We could also compare the range. So again, the range of house prices in Kingston, which is this width here, is much greater than that in Croydon, which would be that width there. To be honest, it's better if you compare the interquartile ranges as opposed to the range. Here is an exercise of questions then I've left in. You could have a go at these. You could go to the PowerPoint and just reveal the answers. So here it asks you to draw a box plot and you've got the information given. So you could just visually check that you are happy with where the information has come from. Again, with this question here, you can just visually pause the video and just check you're happy with the box plot that you're given. Here we've got a couple of past exam questions that you could have a look at. So the box plot shows information about the number of countries competing in each Winter Olympic Games since 1948. Work out the median, so you just need to work out what the value is off here. So reading from the graph, it's 37. The interquartile range, you should be working out the upper quartile, subtract the lower quartile, so just reading off the values from the bottom, so 71, subtract 35 to give you 36. Here, Barry drew an angle of 60 degrees. He asked some children to estimate the size of the angle he had drawn. He recorded their estimates. The box plot gives some information about them. Part A, write down the median of the children's estimate. So this is just reading off this middle value here. And this is 55 degrees. Find the interquartile range. So this is the upper quartile. Subtract the lower quartile, which is 23 degrees. Now having a look at some comparisons. Some students were asked how many times they each used their mobile phones last week. The box plots give information about the male students' answers and about the females. It doesn't actually ask us what to do here, but if you compare them, remember to compare box plots, compare the median. So here we can see that the medians for both the male and the female were the same. Compare the interquartile range, so we can see that the range of the mobile phone times they used them for the females, the interquartile range was greater than that for the males. Okay, Notice here the median time is the same and it is quoted. Both times are 40. The female students had a higher interquartile range, so an interquartile range of 42 as opposed to the males of 31. It is always better in an exam to quote these figures so that you ensure that you get maximum marks. The box plot gives information about the wages of a group of 16-year-old workers and a group of 18-year-old workers. There are 200 workers who are 16 years old. Work out an estimate for the number of those workers whose wages are £130 or more. So if you have a look at the 16-year-olds, so £130, if you read from the scale, is actually the lower quartile value here. So if we want an estimate for a number of the workers whose wages are above, that will be 75% of the data. Because remember, from the minimum value up to the lower quartile is 25% of the data, so the remaining will be 75%, which is the same as working out 3/4 of 200. So there's an answer of 150. Now we get to the exercise for this topic. So I'm proposing a suggestion of you doing questions 1, 3 and 4. I have put all of the questions onto the PowerPoint, so it's entirely up to you if you want to answer more than this. So here's question 1, wanting you to copy the diagram given here and draw a box plot for a different set of information given here. Comment on the differences. Remember to compare the median and to compare the interquartile range. Question 2 if you want to have a go at a different one. Then maybe have a go at question 3. Again, this is comparing box plots. And question 4, drawing box plots. So you'll have to draw the scale into your exercise book and have enough room above that scale to draw both of these box plots to compare. Then you're commenting on the differences. There are more questions as well, but I think doing those 3 questions will give you enough to demonstrate your understanding, and then you can go and have a go at the Hegarty clips that are on the screen now and also in your My Tasks. The answers are all then here so that you can check your answers. Remember to go and use just the normal PowerPoint so that you can work through at your own pace. Thank you for listening.